It's Thursday, 20th of November 2025, and welcome to the Water Action Platform. My name is Dr. Jo Burgess, and today I have some really cool stuff to share with you. I'll be talking to RedStack, a Dutch company that develops electrodialysis membrane stack technology for efficient salt removal and water treatment. I'm talking to the president of Waha, a company that produces pure drinkable water out of thin air using cutting-edge atmospheric water generation technology that just won a Nobel Prize. And finally, I'll delve into how modern epidemiology models have solved a mystery from the French Revolution. But before that, two important matters. First, none of this would be possible without these terrific sponsors. The Water Action Platform, the Executive Exchange, and the Trial Reservoirs are all not-for-profit. These are the generous organisations who cover the direct costs and make it all possible. Thank you. Second, I start today's episode with an appeal. A couple of weeks ago, Hurricane Melissa tore through the Caribbean, killing people and animals and devastating lives. This is Black River, a town in southwestern Jamaica. Before Hurricane Melissa struck, it was a regional hub for fishing, tourism, and local commerce. Now it's in ruins. Now, obviously, the first response has happened. The search for survivors is over, and now it's the long, hard slog back to normal. The good news is we can help. Enter Operators Without Borders, a non-profit dedicated to helping water utilities restore normal systems and services in times of crisis. Even before Hurricane Melissa had reached Cuba, Valerie Jenkinson, the founder and chair, was in the Caribbean herself and mobilizing help. Here's what Val had to say when I spoke to her. Valerie, I know you're incredibly busy right now. Thank you for finding the time to join us. We are seeing catastrophic images from Jamaica after Hurricane Melissa. From your perspective, what's the most critical hidden threat to survivors right now beyond the immediate wind and flood damage?
Well, we focus on the water sector, and there was winds over 295 kilometers an hour. And the water, I was talking to a friend who's got his wife's family lives there, and the water was over their refrigerator. So there are whole areas that look like they have been wiped out by the floods, but we're only just, as in any disaster, communications is always problematic. Roads are down, communications are down. So it takes a little while to get a full picture of what has actually happened.
So can you explain who your volunteers are and what their specific technical mission is in a disaster zone like this?
Yes. Well, we are part of the Caribbean response team. When I've talked to you guys before, it's been about Ukraine. So now we're switching from a man-made disaster to a natural disaster. And the volunteers that we have are, generally speaking, operators running utilities. And they're all volunteers. They generally take holidays to go and help in situations like this. But we also have other water professionals who are disaster specialists. For instance, Kevin Carter was running the WARN program, which is the utilities helping utilities in Florida that some people may be aware of. So he has his bags packed, he has his passport ready, and we're on standby. So as part of the response team, one of the things we don't do is just rush in, because rushing in, we then become disaster tourists. So we wait to coordinate the effort with everybody else and make sure that it's orderly, it's controlled, and we're doing the right things and we're using the right resources. Because when you go in too soon or you rush in and you're not part of coordinated effort, you're wasting resources.
Of course,
so yeah. We have been asked to be part of the rapid assessment team, which is going in and taking a look at what the immediate needs are in the ways of equipment and such like that. Following that, we're asked to make a detailed assessment of the water utilities infrastructure.
And from what that, happens? So when a water system goes down, what happens next? Can you paint a picture for us of the risks that families face when they can't get clean water, they can't get away from dirty water, they can't cook, there's no hygiene?
Well, the humanitarian effort is always there. I mean, the Red Cross is a UNICEF water mission, and they're well equipped to go in with bottled water and they set up reverse osmosis, and we've often helped them because we have such fantastic volunteers, so much knowledge. We can help them set those things up, but it's not a solution. It's not a long-term solution. Our goal at Operators Without Borders is to restore services to the actual utilities as quickly as possible in both water and wastewater. And we are there to lend high-level expertise to go in and to fix things, because my guys can just about fix anything in a utility.
So what's this appeal for? Where does a listener's donation actually go? Where does
For
what
the
do you spend the money
airfare,
on?
for basically to get them there. So we are not funded to get people to the place and accommodation and food. So we're responsible for feeding them and anything to do with their travel expenses. Unlike in many charities, Operators Without Borders funds everything. So we rely on donations to get people. And we've got a little reserve, but I'll tell you, when you're sending 15, 20, maybe 30 people, we don't know how many yet, but that money will go in an instant. Yes.
When it comes to donations, can you give us a sort of a concrete example? For example, what would it cost to get one expert operator to the Caribbean, or what critical pieces?
So generally speaking, we ask everybody to go for a minimum of 2 weeks. And that's selfish because it's the airfare is the same for 2 weeks as it is for 1 week. So we can get almost double the money. The accommodation may be tents right now. We've been told that we may be sleeping in tents. For a woman of my age, that's not necessarily a great thing, but we do what we have to do. And what we've told people, you do everything willingly and with a smile on your face. And we also say, if you're not in great physical condition, it may not be the best for you to volunteer, because this is hard, hot work, and it can be quite exhausting and long days.
There's no nice hotel to go to at the end of the day. So,
but generally speaking, we're looking at about $2,500 per volunteer to get them there on the planes. If you can give us $10, $20,
exactly.
If you are an organization that wants to sponsor a volunteer, we would be grateful for that.
Valerie, we have 1 minute left. So now, speaking directly to the audience, what is your most urgent message for anyone listening right now who wants to help?
If you are in the water sector, these are your brothers and sisters in developing countries. And our volunteers tell me that going to work in these situations often changes their life. Now, you may not be able to go and be a volunteer. You're always willing to sign up, but you can help, because these people are going to work hard. They're going to restore services, and we need your help.
Well, here I am interrupting myself on a different day. That conversation with Val took place on 30th of October. At that time, Hurricane Melissa had made landfall in Jamaica and was on its way to Cuba. 5 days after that, Typhoon Kalmaegi smashed through the Philippines and Vietnam, killing hundreds of people. And just 5 days after that, Super Typhoon Fung-wong devastated the Philippines again and Taiwan. Hundreds more dead, millions of people displaced. This appeal is not limited to Hurricane Melissa, and nor are Operators Without Borders. As climate change intensifies extreme weather events and makes them increasingly frequent, these volunteers need our support more than ever. As Val says, we can all help. Many drops make an ocean. My husband and I donated $50, and if you can join us, please do. We only need 49 more people to do the same, and we'll have paid for a whole operator. Next, we're hearing from RedStack. RedStack develops innovative electrodialysis membrane stack technology for efficient salt removal and water treatment applications, offering an alternative to conventional desalination processes, such as reverse osmosis, and they focus on high recovery, low energy water treatment. I had the pleasure of reconnecting with Paula, someone I know from a long time ago, and meeting a colleague of hers to find out what's unique about their technology and where they're taking it. Tell us a little bit about yourselves and what RedStack does.
Thank you, Jo. It's great to see you again after too many years. I'm Paula Gonzalez. I'm the CEO of RedStack.
I'm Hendrik Zwart. I'm a sales engineer here at RedStack.
Amazing. And what does RedStack do? What's your value proposition?
Yes, RedStack develop and produce the best and most efficient electromembrane stack in markets. And that translates to the end customer into less OPEX, because we use 70% less of electricity in the process, and in less CAPEX as well, due to a very efficient stack.
How does it do that? That's quite a bold claim. 70% less electricity and 30% lower CAPEX. Those are big numbers. How do you do that?
Well, Restart has developed through the years a new design for, let's call it the house of where the electrodialysis process takes place. And this is an optimized distribution flow system that is completely different to what we know in the market. Through this optimization and the design, we reach a better distribution that reach or delivers no leakages in the stack. And that is very unique. There is not another stack that can reach zero leakages at the moment in the market.
That's really different. And your main competing technology will be reverse osmosis, presumably. What's the main difference between RO and EDR?
Great question. The two technologies remove salts, but reverse osmosis do it by pressure, very high pressure. You take water and you force it through a membrane, while electrodialysis is selective because you use an electrical field to remove ions. That means that the water does not go through the membrane, but between the membranes. The advantage of using an electrical field is that ions will react to this electrical field. And this is a selective separation. We focus in the moments in the lower range of, we call it mild desalination. So brackish water that has less of 5 grams per liter of total dissolved solids, because then we see an advantage financially. But I think that Hendrik could take you through now into more detail of what are the applications.
Perfect.
Yes, indeed.
So, Hendrik, over to you then. Where does, presumably you're looking at applications like cooling towers and food and bev and pulp and paper. Can you talk us through where you think ED outcompetes RO and other technologies?
Yes, of course. ED has some clear advantages when you are looking at applications where there's feed water with very low TDS, or if you have very limited resources, so you want to reuse the water as much as possible, then ED has the lower energy consumption than RO and can also reach higher water recoveries. And overall, the technology is a bit more robust, so it can deal better with components such as TOC, COD, silica, but also free chlorine.
When you say high water recoveries, what kind of percentage water recovery are you talking about?
It's mostly, it's a little bit related to feed water, but in the end, you can always reach 80 up to 95% water recovery.
That's amazing. So what kind of applications are you currently focusing on?
In RedSec, we're mostly focused on industrial water reuse or wastewater effluent treatment for use in irrigation, but also looking at locations where it's very high silica in the feed water, and that can then be treated very efficiently with ED.
Amazing. So I'm particularly interested in your application for agricultural water use, because agriculture takes 60% of most water allocations in majority of countries. Do you have an example of an agricultural or a horticultural application?
Yes, I do. We have one case study where we treat the effluent of a horticultural treatment plant.
What was the scope and goal of the case study that you're referring to?
Here we can see the case study of the salt removal of effluent of a horticultural, from horticultural treatment plant. They were dealing with issues and stricter regulations for discharge. So they were looking for solutions to specifically also remove nitrate from the water. And there we wanted to showcase that ED was a very suitable technology to provide a solution for this.
What kind of salt removals and nitrate removals did it achieve? Looking at the table, what was the standout achievement of this particular case study for you and for the user?
Yeah, what we very clearly saw is that we needed to reach a certain amount of desalination, 75 up to 80%, depending a little bit on the feed water. But what we saw very noticeably is that it's very selective for nitrate removal. So with a removal of 75% of salt, we achieved a 95% removal of nitrate.
That's amazing. And what's next for either this particular application or in general? Because these are really high numbers. So what do you plan to do next?
Yeah, to see for other applications where we can implement this solution and get it to the market, of course.
Yeah, of course, we are also scaling up, right? And scaling up means to guarantee lower prices to the end customers. And for that, we are building an automated production fabric that we expect to be running up at the end of the 26, beginning 27. That is the current forecast. And that will help us to guarantee the quality that you need on this type of products, right? The reproducibility that you need and the low cost. And of course, we want to have in a couple of years many references and be able to tell to the world that we are the industry standard because this is the best electromembrane stack available in the market. So we want to see it running in many places through all the world.
Thank you, Hendrik and Paula. So RO is pressure-driven, non-selective filtration. It acts like a fine physical sieve, giving separation based on size. EDR is an electric field-driven selective ion removal process. It acts like a charged ion sorter, providing separation based on charge and mobility. The key message I'm taking away is that the right tool is needed for the right job. While RO definitely has its place, this ED technology provides a powerful alternative for different, equally tough challenges, like brackish water desalination, boilers, and cooling towers. Sticking with the theme of separation, my next guest is Chris Kay, co-founder and president of Waha. Waha produces pure drinkable water from air using cutting-edge atmospheric water generation technology, metal organic frameworks, or MOFs. And when I say cutting edge, I mean it just won the Nobel Prize. The simplest way to think of a MOF is like a crystal sponge built from Legos but at molecular level. You have metal atoms, the nodes, and organic molecules called linkers that connect them. By choosing different nodes and linkers, you can build a crystalline material with a precise, repeating structure of pores. What makes this Nobel-worthy is the unprecedented control it gives us. Before MOFs, making porous materials was a bit like making a normal sponge. You get holes, but they're random in size and shape. With Prof. Yagi's method, we can design the pores to be the exact size and chemical environment that we want. And this gives MOFs a phenomenal capacity to attract and hold very specific molecules, like H2O. I was lucky enough to speak to Chris just after the Nobel Prizes were announced, so here I am, trying not to fangirl too much. Chris, huge congratulations to your co-founder, Professor Omar Yagi, on his Nobel Prize. It is a monumental achievement for reticular chemistry. For our audience of water professionals who aren't all chemists, can you break down what a metal organic framework or a MOF actually is and why it's a Nobel-worthy breakthrough?
Sure. So first thing, just as the Nobel Committee said, it's a very unique material. It's comprised of both organic and inorganic compounds. In our case, the water harvesting MOFs. So Professor Yagi invented MOFs back in the early 90s, but invented his first water harvesting MOF in the 2010s. And the Nobel Committee likened the MOFs to Hermione's handbag. That basically it's incredible what you can put inside of it. So 1 teaspoon of the material, if fully unfolded, could cover an entire football field.
Wow.
So it's an incredible, basically framework of materials that can each be uniquely designed to capture and separate out one molecule from a molecular stream. And in the case of what we're talking about, separating water molecules out from an airstream.
That's a fantastic explanation. So it has this phenomenal capacity to attract and hold specific molecules, and in this case, water. That's a fantastic explanation. So you have this incredible material.
Mhm.
The company was founded in 2018. Can you take us back to that moment? What was the spark that turned this Nobel-winning chemistry into a company specifically dedicated now to solving water challenges?
Sure. So our initial mission statement was to provide safe drinking water to underserved communities in water-starved areas of the world. And that's a beautiful mission statement. That's why I joined. That's why all the original co-founders joined, is to deliver on that mission. And our company and our technology is uniquely positioned to deliver that. However, we also realized quite early on that that mission statement, while beautiful and something we can do, is not fundable. So we have worked to find solid markets where there's solid economics to provide either pure water or dry air, because taking humidity out of the air creates dry air. So there are plenty of strong economic value propositions. And we combined Professor Yagi's moth material with a uniquely designed, that we've patented now, desiccant regeneration engine that can regenerate the moth very efficiently any place around the world.
Amazing. Okay, so now you've got the moth, which is Nobel worthy by itself. You've got now a way to regenerate it, which actually makes it applicable and usable in the real world, which then becomes bankable materials, bankable projects.
Mhm.
Okay, amazing, amazing. So beyond harvesting water from air, how else can this sort of crystal sponge technology revolutionize the work of water professionals like this audience? What specific problems in water treatment and supply can you solve with it?
Sure. So several things. One, the material itself, focus on that. As I mentioned, it separates water from airstream. So the pore size is very small, and really only water molecules will fit inside of it. So volatile organic compounds, pollution won't. So I live in Colorado, our labs in California. You can run it in either of those places during fire season. You can run it in India or China, any place that's polluted. And with no additional filtration, all you get is type 2 ultra pure water. So that's one thing. So you get very pure water. The other thing is that moths can adsorb water at relative humidities down to 7%. So in very arid conditions, so we have machines running in Riyadh in the UAE and in Sweden, so where it's cold, so it can supply that. The other thing is that we're not competing against traditional sources of water. We want to supplement them because the water we provide is very pure potable water, or can be made potable by adding minerals back in. So it's a supplement to what professionals do. So no PFAS, no microplastics, heavy metals, nothing, just pure water.
So if I've understood this correctly, then it's like a precision filter that just pulls the water molecules away from everything else. You don't have to find a water source and then try and remove things like PFAS or toxic metals or specific industrial pollutants out of the water. When you get it, it's already pure.
That's it. So, right. In fact, again, we like to think of it as, not even think of it, we call it a nano separator, not a filter, because it separates out water molecules from everything else in an airstream. And then our engine makes a very efficient way to regenerate that, so we can get the water then out of the material and condensed into something to either be used for drinking or for agriculture or pharmaceuticals, or obviously many other things.
Okay, it's absolutely transformative. I cannot overstate how disruptive this technology is going to be. But for the sake of the audience, again, if you look ahead 5 to 10 years, Chris, what's your vision for the role that Waha, your company, and that MOF technology will play in creating a more water secure and energy efficient future?
Right. Well, one of the things is that if you look at us like a server farm or a disk farm, also like cell phones, we're we're a distributed solution. We're not a centralized solution like what water utilities professionals have been dealing with so far. So you can put our machines out and scale them anywhere. And because our machines are small and be used to fail over one to the other, we can provide, and we already have 5 nines, working towards 6 nines of reliability just through a bunch of small machines working together. So very scalable, low cost, high reliability, pure water that you can. So instead of dealing with just one central facility, then you can deal with many others. The other thing is our business model. We want to sell water, not machines. So that's what water utilities do. And ultimately, we think we can provide the most sustainable water solution by helping water utilities and consumers at large take the bottle out of the bottled water market. Because instead of sourcing water or providing bottled water where it's sourced, we provide water where it's consumed. So you eliminate all the packaging, you eliminate all the distribution, you can generate it anywhere in the world.
Fantastic. And it's much more economically viable because we all know with water, we have the opposite of economies of scale. The more you want, traditionally, the further you have to go to get it. Whereas in this case, you're generating water right where it is. So it could be anywhere. That's amazing. Chris, this has been an incredibly insightful and compelling discussion for the use of MOFs for decentralized, for ultra pure, for water, for almost any situation, in any situation. Thank you so much for sharing the story and your vision with the audience. For those eager to learn more, where can they find information about MOF and about Waha and what you do?
Well, about MOF, you could check out Professor Yagi's website at University of California at Berkeley. I can tell you what he's researching on MOF, but in terms of how we're using water harvesting MOFs and integrating it with machines to deliver safe drinking water anywhere around the world, check out our website at www.wahainc.com.
Thank you, Chris, for sharing your story of the spark of academic research and its journey into application in the real world. And finally, do you, like me, hate gossip? Do you feel as though rumours spread like disease? Well, you're not wrong. What was the Great Fear? If you know your European history, you'll know all about it. The Great Fear was a period at the beginning of the French Revolution when fake news spread throughout France. Between 20th of July and 6th of August, people all across France mobilized at stunning speed in response to rumors of an aristocratic plot to starve out the population. People formed local militias who were obviously not able to find any real culprits, and they destroyed property and burned documents. Now, the reason we're talking about this here and not on a history channel is the way that public health methods have worked out how this conspiracy theory spread and how the riots erupted where they did in only a matter of days, long before telephones existed. Statistical modelers and pathologists applied epidemiology to the precise dates and locations for each uprising, collected from letters and accounts written at the time. The Great Fear spread at a speed of about 45 kilometers a day along France's road networks. About 40% of the uprising locations were near a postal station, showing the importance of communication pathways. The researchers combined mapping data with demographic and economic data, such as literacy rates, wheat prices, and land ownership rates. And the places where riots actually broke out were densely populated, literate towns where the income levels were average, but the food prices were high, and they had low levels of land ownership. The team showed that the Great Fear's spread followed an infectious diseases trajectory, infecting quickly and peaking on the 30th of July, just before dissipating, much like a virus. The key difference here, though, is that the plot to starve out the people never actually existed, although the consequences certainly did. Today, information spreads much faster than 45 kilometers per day. It doesn't matter whether a rumor is true. What matters is whether we fall for it. With that, we come to the end of this month's broadcast. Once again, I thank our amazing sponsors shown here. The next Water Action Platform will be on Thursday, 18th of December at the usual times. Once again, we'll be coming to you via LinkedIn, so follow the ION Media stream on LinkedIn to subscribe. Until then, keep asking questions, keep sharing whatever you can, especially with Operators Without Borders, and keep yourself and help keep others safe.